Hello, Paul Frobisher, Strategic Innovation, and welcome to this talk. So this is a presentation that was originally given in May 2024 at the Future Food Symposium at Nottingham University. It wasn't recorded, so we are fixing that now. It's about 30 minutes and it's about innovation, systems thinking and food policy. But as I said at the time, if you're going to take one thing away, you can take away this one thing, which is that a great solution to the wrong problem is a bad solution. And so in the food system especially, bad solutions have very nasty consequential effects, no matter if they are unintended. And so we need to spend as much time as we can fully understanding and defining our problem before we jump into those solutions. Okay, so the first thing is a bit of introduction. So strategic innovation, we tend to focus not exclusively but largely on FMCG and the food sector, and we have a very close relationship with Daryl Mann of Systematic Innovation, and you certainly cannot characterise Daryl's work as being focused in any way on one sector or even a few, because what Daryl's life's work has been about and is continuing to be about is about excellence in innovation no matter where that is found, and then unlocking the secrets to be shared broadly. And so certainly my career, and if not my life, changed when I first read Hands-on Systematic Innovation back in about 2003, and we are currently working together with Daryl and the team to train up around about 3,000 engineers in one of the world's largest tech and communications company in troubleshooting. So it's their troubleshooting engineers, and there is a forthcoming book on that topic which could be characterized as bringing troubleshooting techniques kicking and screaming into the 21st century. So in terms of this talk, what we're going to do is we're going to apply some of those broad techniques and just three particular key tools to apply to look at this sort of systems thinking and thinking about problems part of the equation, and show how it works with the case study of Oman. And so you're going to take those key learnings away with you, and hopefully how to apply that to the food system. But also we launched something called Think Better World at the symposium. We're very proud and pleased to do so. So I'll just explain a little bit about that at the end as well, because it sort of follows on quite nicely from what we're going to talk about. And what that is this setting here. So if you look at the image, it's the interior of Oman, and it looks like a desert because that's exactly what it is. But in the distant past, the food systems of Oman looked like this. So it's called the affleage system. It's a polyculture, multiple different types of crops and produce mixed in with animals and people into this rather idyllic food production system. And there's very few left. They're World Heritage sites. There's I think a couple in Morocco as well. There's very few of them around the world that are still operating like this. But if you ever get a chance to see them, definitely grab it. They're amazing. But they're very rare, and what has replaced them is the modern interpretation of dry land agriculture, which from a height looks like this. So these are quite large discs in the desert, and they are what are called center pivot irrigation systems. And what happens there is you have a borehole in the center which is going down, extracting water from the water table underneath and spraying it onto the soil. And when you do that with all the right chemicals and fertilizers and crop protection and the right seeds, makes you a lot of food very quickly and very efficiently. Unfortunately, there's a downside to this, and that's that you can characterize in many ways in very similar to all of the industrialized mechanized food production systems around the world, you can say they're degrading. So they're degrading the ecosystems, perhaps most worryingly the soil, as a consequence our health, and with that lumpy allocation of the proceeds throughout the supply chain, also the wealth. Why? Why do we do this? Well, at the end of the day, it's us, isn't it? It's our management of those landscapes. Food, at the end of the day, always comes from landscapes. And it's our mindsets and also our minds. So the temptation is to think, well, it's those globalist, capitalist, thieving multinationals, isn't it? That's why it's like this. And you can see why you would. That's a reasonable position to take. If you think a little bit more historically, what you find, this lovely book by David Montgomery called Dirt, where he looks at the patterns of destruction of what happened in Roman and Greek societies, where there's a definite correlation between the collapse of the fertility of the soil, which seemed to contribute to the demise of those great civilizations. Obviously, going to be not just that, but there's a definite thing that seems to be a recurring pattern across all the world and across time, that humanity has this sort of self-destructive death wish, really, when it comes to our ecosystem. And so in order to deal with this and understand it, we kind of need to understand our thinking and those thought patterns. So it's nice to think about people who thought about thinking. And one of those people is Edward de Bono. So he's known for coining the phrase lateral thinking, but also six thinking hats. And one of his lesser known pieces of work is this water logic, and in common with others, has this sort of water flow in the landscape metaphor. So here we can see these streams which are embedding themselves and establishing themselves in this sort of tributary system. And if we think about how we learn, for instance, so if you're a concert flautist like this, you probably started off annoying your parents with a recorder or something, and you've gone through this learning curve and this important S-curve we're going to come back to later as well. But when it comes to our brains as we grow up, we can't always think from first principles, so you need to learn, and these are the shortcuts, these are the paths that we bed in these habits and thought patterns, which are good because they make life quick for us, but it's also bad at the same time in that we get stuck in our ruts, aren't we? And there's 188 cognitive biases, which are lovely. This are very helpfully summarised in this nice piece of work here. So, for instance, these are all these things you can't see are defined cognitive biases. We will have them, and a really popular one, of course, is confirmation bias, where we really look for data sources and opinions and people which bolster our own predefined preferred opinion. But there's good news. So there's people like Annie Duke, for instance, who's a world championship poker player turned psychologist, and she's using the knowledge of psychological inertia, if you like, or these cognitive biases. If you understand psychology and you're having to make decisions like you do in poker, then you can use those downsides to your advantage. And we think that's good. We agree with that. Understanding the people part of it's important. And that brings us to the next part of the story, which is what we do with troubleshooters, is say, right, okay, so you're about to parachute into a problem situation. So understanding the characteristics of that environment are important to decide how you're going to tackle it. And this brings us on to this idea of complexity, understanding complexity, and the work of Dave Snowden, currently of Cognitive Edge. But when he was at IBM, he developed this model called Cynefin, which breaks down the world into these four kind of segments or environments of chaotic, clear, complicated, and complex. And his argument and his work is about understanding how you work with problems in those different environments. And what we've done is we've added a second dimension to that. So we have to understand, the first question is what's the situation complexity. The second is what's the human complexity, or what we call the anthro-complexity. So what we tend to do is have this axis of situation complexity. We don't tend to have chaotic situations that we're working in, emergency situations like that. So it's about this sort of non-complex to complex axis. And to describe the difference between complicated and complex is probably the more tricky one. Well, we do that with chess versus poker. And what we would say is that chess we would describe as on the sort of complex side of complicated. So chess has a set number of pieces. Both players can see all the whole board at all times. There's nothing hidden. The rules don't change, and there's nothing. It's all down to the skill of the next move. And at any one point in time, there's kind of like your best option, your best move. And obviously computers can help you work that out. But the skill is understanding what that best one move is. With poker, on the other hand, you get dealt a hand, and if you've got a really good hand and you play it in exactly the same way in a game, you're going to basically have different outcomes. So there's no direct correlation between the decisions you take and the outcome you get, and that's a big part of Annie's book. And so realizing that, you also then can start to think about the human side. So with chess, there's two players. There's a lot of mind games go on, no doubt. But clearly with poker, that's up here, because at the end of the day, there are, part of the fun of poker is the mind games and understanding what other people are going to do and looking at the psychology. So now the question is, so imagine that we're now a troubleshooter going in to troubleshoot the food system. Where would we characterize? Is it poker or is it chess? And that's an interesting question. So, where does the food system go? And what we would actually say is that it depends, doesn't it? Like with so many things. And certainly the food system as it is, in many cases, is down here. So the discs in the desert, you can say what's happening is you're looking at these industrial approaches, which in common with other things like the controlled environment farming, these vertical farms, you're taking all the variation out of it as you can. You're making it as controllable by breaking it down into its constituent parts that can be measured and managed. And we don't necessarily in the food system itself really think about the human factors. We know we're kicking families off the prairies and being replaced by big corporations, big factory farms, and so on. So that's what we're doing. That's what we've done, in fact. But like the affelage system, really, nature. If we think of the food system as being part of nature, and that we are actually part of nature, then actually the reason that there's this big difference is because that's where nature wants us to be. That's how it should be. So the lesson from this, and I think this is perhaps one of the bigger takeaways, is the reason why this, and probably quite a lot of other things, is that we have many tools for thinking down here, the scientific method and other things, the way that we're taught to think, we naturally think, we operate down here, and there's very limited things to be approaches to help us here. And so what we need to try and do is, fit our thinking to the system as it should be, not making the system fit our thinking, and which is, the fundamental issue. It'd be interesting to see how people agree or disagree with that statement. if we're thinking up at this top right hand of the box, you can really be thinking about sort of systems thinking, and you're not going to go very far in the literature before you come across Stafford Beer and the viable systems model. So it's a really good body of work, really, which is looking at the science of organisation, but really it's like almost like that it's an organism as well as an organisation. So this idea that it's almost like a pattern of the way that things work as an organism applies to lots of different types of organisations, and you can use the viable system model as a way of understanding what's going on, and therefore but doing it at the system level. Obviously can't go into the detail of this, but people like Patrick Hoverstadt, so big shout out to Patrick. This is the idea of using viable systems modelling as a platform for then understanding and then looking at these sort of like these fractal levels of different hierarchies of operations, so that you're looking at solving the right problems at the right hierarchical level and applying the right patterns of strategy. Now, our contribution to the same approach of looking at innovation as a process is what we call the innovation box model. So putting innovation in a box, which is a revolutionary idea, but it comes from basically a disciplined process modelling tool called IDEF0, which says that any process has inputs, outputs, controls and mechanisms, and any verb is a process. To innovate is a verb, therefore it satisfies the requirements of the IDEF0 modelling. And so this is what happens when you model innovation through that process. And so what we have in the centre here is sub-processes. So these also are the same icon boxes. So we operate something, a factory or something which is creating goods or services, and that's being used. So this is the idea that production and use and the customer and the factory are part of the innovation process. And then we've got this sort of plan, deliver and launch processes, which are putting new things into the system at all times, like an organism, like your I don't know, respiration system or something. So what we're doing is that we're saying at this top level, innovation done by people within an infrastructure using tools and methods, and we're taking the inputs of knowledge and IP, turning it into new knowledge and IP, turning natural resources and energy, putting it through these processes, which are then creating this impact, both positive and negative. So you can make sure, obviously, noting that, and also tangible and intangible impact. And of course, intangible impact is really difficult to measure on the positive and negative side. And we're looking for a positive output to our investment to make it worthwhile. But what actually determines what good output is, the judgment on good or bad output, is these controls. So the controls of the voice of the customer. So what problems are customers wanting to be solved? What jobs do they want doing? Do the solutions obey the laws of physics, chemistry, and biology, and so on? And also, are we legal? So are we obeying the laws of government and business? Are we in line with trends in business in terms of what business strategy is looking for and what government's policy is seeking for us to do, like Vision 2040 in Oman, for instance, we're going to come on to. So that's another of the tools that we use on a regular basis to kind of contextualize situations. And another one is going back to these S-curves. So if you take something like the internal combustion engine, it has this value to society, or which is and to customers. So in terms of what we call ideality, that's like a simple equation between like the things that you want, the good things you want out of a car, divided by the costs and the harms of the bad stuff. And another way of thinking about it actually is the fit. I think this is quite a good way of thinking about it, that what happens is over time, the fit between what society is looking for and what's delivered closes, and also society. So if you think about what's happening here, society's expectations or the market's expectations can be going up. So it's just really the difference between what you're delivering and what is required, and that's really where this pattern really comes in, because pretty well every system has these contenders which are coming in to disrupt this black incumbent curve, and some of them will come in and maybe take a niche like this bottom one here, maintain a presence. Some are come in and disappear. There's many of these. It might be that for every one black curve there's like 100 that come in over time. But the problem is that when you're in the incumbent, there's sometimes one, maybe through some chaos, through black swan event, they call them, and there's a system which looks like the black curve that isn't, which actually comes in and actually disrupts and takes the market completely, because it's fundamentally more capable of delivering a better fit, more ideal and a higher value to consumer and society. So you've got to watch out for those, and what we spend time doing then, of course, is using the box model to understand the fundamentals of what's going on in the incumbent, and then imagining what these potential winners would look like, and understanding the difference, because there's some big differences between especially the infrastructure, for instance, between one system and the other, and that's normally what makes these other ones fail. So understanding what's going to unlock the transition is the key to picking the winners. And that works, energy sector, pharmaceutical, whatever you want to know. It's all the same across the board. So that's all the kind of the three main concepts that I want to share today. So what happens when we look at a case study and lovely Oman? It's a wonderful country, and we're very privileged actually to be asked by the Ministry of Agriculture and Fisheries to look at developing a national strategic framework for the nation, and with respect particularly to maximising the economic impact to create employment, because they're a nation that's transitioning from oil and gas. That's for obvious reasons. That's a key part of what they need it to do. They're struggling to maintain output from their farming sector for the reasons that they're degrading their soils. We've got desertification and salinity ingress around the coasts, all sorts of problems, and so it's a big challenge just to maintain it. So the stretch really for them was to say, well, could we increase output by 5 to 10%? And whilst doing that, align with Vision 2040, which is kind of this sustainable development goals of Oman, and it's their North Star of development that everybody knows about in the country, and it takes sustainability and nature into the equation. So what we did is we were really, using these tools, looking at how since 1972 the modern Oman has developed. What is Oman like? What's the ecosystem like? What are the people like? What's the anthropo-complexity like? And then also looking into dryland agriculture, what are the technologies that are available, and therefore what of the available technologies, what are the things that are really going to make the difference and fit best in Oman. And so to cut a long story short, we can think, we're looking for what are we trying to do with this new, what's current and what's a new system. And you can characterize Oman as having limited productive land. It looks like this, and what we could say is that's a really it's an unfair disadvantage. Really, it's not great if you happen to be having to be a nation in that very dry, hot environment. Even on the coast, it's very difficult to grow stuff. So our vision, we looked obviously using these tools at the top right of the anthro-complexity box, the realm, and we started to think like this. So we can say that we have seaweed aquaculture in obviously off the coast, which is a topic in itself. But we started off looking at integrated seawater agriculture using mangroves, and around many places around the Middle East, there are these giant shrimp farms, mega farms, which are going in, creating a lot of effluent. They're pretty well environmental catastrophes, really. They know it and they try to mitigate it, but at the end of the day, it's a monoculture of shrimps producing a lot of effluent. However, you can turn that really harmful thing into a good input to mangroves, and you can turn rivers inland and actually put seawater into these mangrove swamps. Mangroves are a horrendously good sequesterer of carbon, and they grow very well with effluent pointed at them. And you can integrate that with all sorts of other activities, bivalve aquaculture, other salt-tolerant crops, and so on, and create an ecosystem which is both sort of like the biological ecosystem as well as a commercial one. And so regenerative resources, if you want to look that up. And another one we came across was the work of Charlie Payton of seawater greenhouses. And this is a wonderful technology, very, very simple. It's been simplified over the years by Charlie and the team. And it's basically evaporating salt water through cardboard honeycombs to create a lower temperature inside what you call greenhouses. They started off as greenhouses, more like green tents now, which means you can irrigate and grow lots of food at really good temperatures, even if it's 40 or 50 degrees outside. But the remarkable thing they found was that by having these tents that are leaky, it actually leaks the humidity into the landscape, creating this what we call an oasis effect. Now, done on scale, and in part and together with the mangroves, which also do a similar thing, you're basically putting in vegetative transpiration, which is putting like a natural cycle of what we call the small water cycle, and starting that back up again. If you do it on a big enough scale, what happens is as you go into the interior towards the mountainous areas and the lower temperatures, you can at some parts of the year potentially start to turn the rain back on. But also, even if it's not raining, we suggest agave agroforestry. So agave is a plant that requires, once it's established, no actual irrigation because it gets all of its moisture from the atmosphere, and of course putting that downwind of the agroforestry systems and the greenhouses means you're giving it all the chance that it needs. That then stabilizes the soil, reduces the ground wind speed, allows other crops to thrive, potentially grazing. And then behind that, this regenerative grazing, where again you're allowing the landscape to its best opportunity to regenerate, and you're introducing ruminants back into the system, and also stimulating nature as well. So the upshot was, how did it fit? And we were shocked actually what we were able to present back. We had no idea about this before we started, and we were very, very happy to present what we did find. So this sort of regreening thing, it wasn't about 5 to 10%. It's 5 to 10 times the output of food, just because there's so much land that is doing nothing, and they could transform this land just really with the input of boundless saltwater and minimal, if any, freshwater input required, and obviously then with the potential benefit of totally regenerating the landscape. For instance, large areas of the coast of Oman historically had mangroves around, and the thought from the literature is that a lot of those were actually taken out by ancient civilizations, over exploiting them for wood, for firewood, for grazing, for the camels, and so on. And in those brittle environments, it's very easy to collapse the landscape and switch the small water cycle off, and everything collapses. So what we're looking to do is use that and actually turn it back on again, and everything comes back. that's the plan. So we're making Oman green again, which is it's just thrilling, really. So coming to the end now, and so just to recap, really looking at how to make a better world and how to make a better food system. What we're looking at doing is thinking, well, we've got the system that we're looking at. We can characterize a system with those sort of system thinking tools. And one reflection that we have is that we love working with our clients, and quite often if we're working on single projects, we're working with like a new ingredient or a new food product or a new part of the factory or something like that. What those are is what we call them point solutions. And of course, if we're implementing point solutions at this part of the system, or a system that's behaving like this, really they're actually pointless solutions, because what we want to be doing is getting up to the top right. And what we believe is that to take this journey, this is what the Think Better World journey is actually to move our understanding up the way and we realise there's a real gap in understanding consumer and society, especially in the NGO community. People that really need to know what's going on don't. So we want to help, and so this is the sort of the blast off rocket that we want to happen for the Think Better World Alliance. And for that alliance, we want to hear from you. We want you to join us, to get involved. We're really delighted to be working on a knowledge transfer partnership between Innovate UK and the University of Nottingham. We've got a fantastic team, and never underestimate the ability of a small team to make a massive difference, given the right team and the right resources and the right vision. So we really think we've got that right vision, and we want to apply it and make a difference. So we want to come together for food system sustainability. We'll be really at the beginning of the journey, and we don't really have much idea about what it's going to be like. So we want to make this work with our alliance and see where we go with it. But we've got some really big ideas, and hopefully some really good ideas, and you want to join us. So sign up, talk to us, contact us, maybe even in the comments here. I'd love to hear your thoughts, and thank you for listening. It's been a pleasure to recap what happened in May 2024. Thank you very much.